Good morning, everyone. Thanks for making it along today. I will be presenting in English, I'm afraid. My Scandinavian languages are very limited. I think I can order a beer and that's about it. So I apologise. What I'm going to do today is talk a little bit about web-scale technology and BigTec in particular. A little bit about Exclusive Group, so that you know who we are. Exclusive Group is about driving disruptive distribution. We're here to try and help our partners create a new way of going to market with new products and a disruptive approach to take the existing markets and to cause some disruption in a positive way. So that's ultimately what we're about. It consists of four major divisions: the cybersecurity division, Exclusive Networks; BigTec, which we're launching today here in Sweden, which is the data center transformation arm of the business, and that's what we'll be focusing on today. However, that's supported by finance, which is Exclusive Capital, which is finance and leasing for the types of operations that we perform. And finally, also by iTech Global, which is our services arm, enabling us to provide entire project-based and project management across the world in 106 countries currently. So that's the business as a whole. Founded in 2003 and all the other things, but we're quite large. We're covering more and more of the world as we go along. World domination definitely is the target, and we'll work on it slowly. Okay, on to the virtualization piece, because this is what we're really here for. Virtualization landscape has changed dramatically in the last 2 years in particular, we think. And we see a big change coming. Over the next 2 years, the market will be worth about $235 billion by some estimates, and there are varying estimates. No matter which report you look at around virtualization and the changing of the data center, there is one trend, and that is more change and more money being spent on that change. 55% of the workload, of the server workload, has already been virtualized. That's happened over the last 10 years probably. But during the next year, by the end of 2016, 86% of the server workload around the world will have been virtualized. So it's a big change, and a lot more rapid change is taking place now. There are 15 million plus virtualized applications already, so lots of different applications used by lots of different people in different markets. By us as users of things like Uber, which is massively virtualized, Google Docs, Apple's services, all the rest of it through cloud, but also within our own private data centers. Virtualization has massive benefits. By 2017, 60% of enterprises expect more than 50% of their applications to be in the cloud, either infrastructure as a service or what I call real cloud services, like Office 365. So we're seeing that change continue. And what drives it? There are three principal drivers for virtualization. First and foremost is that massive reduction in the hardware. In other words, better utilization of the hardware that we already have. So we end up with reduced hardware and infrastructure costs. If we reduce the hardware, we're reducing the power consumption, the cooling requirements, the space requirements, and of course, ultimately, staffing. Number two driver is scalability, and that ability to change and flex the capacity within the organization to meet the changes in demand. So as some organizations see massive fluctuations throughout the day, throughout the week, throughout the year, you can change elastically the compute and storage and application capacity for that organization. What we'll end up with, to my mind, is actually hybrid organizations. We'll end up with organizations that have some element of their own private cloud, their own data center, which will be virtualized, and they will be using some elements of the cloud applications and infrastructure as a service. So that has been our guiding principle in looking at what we believe is needed to create the next generation data center. Of course, the final one there is reduced staffing and administration costs. That is another big expense in any data center, in any IT organization. So there is a big drive to reduce the manpower that we have allocated to this system. So those are the drivers. Ultimately, we can summarize it to do more with less. That is ultimately what we're aiming to achieve with virtualization. But there are some challenges with that. There are some difficulties that we need to address. And they're not new difficulties. They're the things that we face in conventional data centers. But they become more difficult and need more time to address when we look at hybrid data centers. So security is a big one. And as we see every day in the news, there's a security issue for almost all of the major names, and we'll see a lot more over the next few years. It isn't something that's going to go away. There will never be a perfect security solution. We will always have breaches, and what matters is how we deal with them. So there are the security challenges. How do we create security in a hybrid, cloud, private, virtualized environment? The next one is data governance, which is sort of related, all those compliance issues. How do we look after the credit card data when it's in different locations? How do we look after personal data? All we have to say is the Ashley Madison these days, and everyone knows what we're talking about there. So there are data governance, PCI DSS for the payment card industry, and all of the other pieces that go with it. Data privacy laws, safe harbor, and all the difficulties that there are with that. And that will be another changing environment. The laws that will be applied and the data governance required will be another area of constant change. Technically, the big area of difficulty is integration. How do we get local installations within our own private data center to work in harmony with cloud applications and with applications and data that we've put into infrastructure as a service in the cloud? So those are challenges that we'll have to face. And finally, when we've created this sort of environment, managing it. Managing a hybrid cloud infrastructure service and private data center infrastructure will present new levels of difficulty. So at first, it all seems quite negative, but it doesn't need to be. These are just opportunities. They're nothing new that we have to deal with. They are the challenges that have faced us in our own data centers for years anyway. It's just how do we adapt these solutions, the solutions we have currently, to work in this newer virtualized environment. Okay, so those are the challenges, and those are what we'll be addressing in today's session. One of the things that we're aware of is the conventional approach of using appliances, fixed hardware, expensive servers, etc., has changed. The requirement to use fixed purpose devices is changing. As the silicon that we're able to access, the merchant silicon as we might call it, the standard tin, to use another phrase, has got faster and cheaper, there is no longer the requirement to have specialist devices. Things that used to require specialist hardware can now be done in software on merchant hardware. So that is another change that we can encompass within the changes that we're applying within the virtualized data center. We can use standard tin to do what previously required specialist hardware. There are some of those demands, the IT department, or the demands on the IT department. There are several things. The first one is time. We expect within an organization currently things take weeks, and the average is about 8 weeks to roll out a new application. 8 weeks, sometimes a lot longer. And in one organization I was speaking to a couple of weeks ago, it was taking them upwards of 4 months to roll out a new application. From the point where they knew it was ready, they'd done their testing, to the point where users were able to use it was 4 months. That's not the dynamic movement that an organization is looking for. That's 3 or 4 months in that case of lost competitive advantage. And in fast-moving markets, that's too long. So the demands on the IT department are to be able to make those kind of changes in minutes. And ultimately, we have to have the target of being able to make those changes, those rollouts in seconds. Now that might seem far-fetched, but if we look at if we look at the demands of agile software production, we need to make minor changes to software on a very, very, very regular basis. We need to be able to make rapid changes across the whole organization very quickly. So that seconds target is important. The next one is cost. A standard fixed hardware data center with fixed functions, fixed servers, fixed applications is a big space using a lot of energy, a lot of power, a lot of cooling and a lot of space and a lot of people. That's expensive. So virtualization allows us to reduce that, to produce the same with lower power, lower cooling consumption, lower numbers of people and smaller spaces. But ultimately, we'll need to do even more. We'll need to be able to scale faster and to make even more happen with smaller levels of hardware. And we'll be able to do that because of the changes we're seeing in the hardware available. And finally, control. In the old model, we only had a few buttons that we could press to make the changes, very fixed hardware. It would be difficult to make changes, so we're very restricted in what we can do. In the current environments, as what I call first or second generation virtualization, we can make those changes more quickly, but it's a little bit haphazard at the moment. It can be very difficult to get things right, and things go rapidly wrong, and we end up spending a lot of time in that data center fighting fires, chasing problems. So ultimately, we want to have a lot more control, but that ease of control that we used to have in the fixed environments where we knew what was happening and everything was stable. So we're looking for very difficult answers, if we think about it, to do a lot more with a lot less and to do it more predictably with more control. That's the goal. So virtualization and the abstraction layers. Virtualization, obviously, we've already abstracted things. The first generation of virtualization was where we used virtualized servers and virtualized environments for training, for software development, for testing. The second generation was where we started to virtualize the workloads, the actual operational workloads. And that, when we start to do that, we start to see some new possibilities. The ability to start multiple copies of the same application on multiple servers. The ability to have high-speed failover when one application is failing or one server is failing, to move that to another one. So we started to see more agile data centers as an option. The third generation is where we take those levels of abstraction of the server and take that further across the organization. It's no use being able to just move copies of the application if the underlying storage system and the underlying network that are supporting that are unable to respond as quickly. So what we need is to be able to virtualize the other components. We need to be able to virtualize the desktops, virtual desktop infrastructures, which we're already seeing. We need to be able to virtualize the storage so that the storage can be as flexible as the server environment itself. And we need to be able to virtualize the network. The last component is the network, and that needs to be virtualized so that it too can change in response to changes in the demand and the requirements of the users. So all of these need levels of abstraction. There are loads of buzzwords that have appeared: SD-WAN, software-defined wide area network, the data-defined perimeter, all of the rest of it. To my mind, the one that really matters is the SDDC, the software-defined data center. That is the target. That is the goal. Everything must be done in software. So let's look at the stack. The Webscale solution stack, if we look at where we were, all the endpoints spoke to the network, a fixed network, fixed endpoints, speaking to applications on a fixed compute infrastructure. The first level of abstraction was to virtualize that server workload. So with the hypervisors, the VMwares of this world, Hyper-V, KVM, and as you'll see later today, Acropolis, there are options for having a software virtualization layer which separates the operating system and the applications from the underlying hardware. As soon as we've done that, it's now possible to take that whole operating system and the applications it supports and move it to different kinds of hardware with ease. Because what that software is looking for is a fixed virtualization abstraction layer. So it looks the same wherever it goes. Only that abstraction layer needs to know about what hardware it's working on. So that's the first stage. With that, we also need to virtualize the storage, to make the storage as flexible as the operating system and the virtualized application layers themselves. We need to be able to move storage and allocate storage as quickly and as simply as we can move and allocate server capabilities, server applications. So that is where we start to look at the components we're adding, and in our model, that's Nutanix. You'll be hearing from our guys at Nutanix a little later today. Nutanix gives us this highly scalable software in terms of a support for hypervisors, that abstraction layer, and that abstraction layer works across multiple kinds of hardware, lots of different hardware, and gives us virtualized storage, virtualized compute power. So we have highly scalable, highly flexible compute and storage. And that is the core component of the Webscale architecture. The ability to add, as quickly as a few minutes, new hardware, new software, which adds to that capability more storage, more compute, more CPU, more memory, in such a way that the applications and the server layers, the virtualized components, can get access to that straight away. So that's what Nutanix gives us, the massive scale for the virtualized hardware and the storage that goes with it. So applications can now move rapidly across an ever-expanding hardware infrastructure. That's all very well until, if we're able to spin up multiple copies of an application and move it around, that's no good if the network isn't going with it. So we need to be able to redefine the network layer so that an application, if it moves from one server to another, that the network changes in to correspond with that. If a new version of that application spins up on another server in response to a demand change, then the network needs to be able to change. And we can't wait 8 weeks for that network change to take place. It needs to happen now. So that's where the software-defined network layer comes in. And in our model, we're using Nuage Networks, which fits and gives us that abstraction layer for the network. There are still switches, there are still routers, there's still all the wiring. That has to be there. But how it's used and how the applications and how the servers get access to it is moderated by the abstraction layer of Nuage Networks, allowing us to make rapid changes to that network in software. Another component then is how do we manage all of this? We talked about the 4 challenges, and one of the big challenges was how do we manage performance in an environment like that, where I'm spinning up new applications, closing them down, moving one application from one data center to another simply because it's cheaper in that data center, or there's more capacity or more space available in that one. That needs managing. And to do that manually, well, you can. Good luck with that. I wouldn't recommend it. What matters now is our ability to make those changes to that environment in response to the changes that we're seeing, the demands. And that's interesting. We talk about the demand. If we look at the entire data center as an economy, there is supply, there is the capacity of storage, compute power, network, and resources in general. So that is the supply side. The demand, which applications currently need to run? How many versions of that application need to run? How much storage do they need? How much CPU and memory do they need? Managing that in a big data center is the nightmare, and it takes hours and hours of our networks teams, storage teams, server teams, and applications teams every single day. It is an economy, and the way to work with that is to have something that responds to it and understands that as an economy, and that's what VM Turbo does, another component you'll hear of later today. VM Turbo treats the whole system as a supply and demand economy. It knows what the supply is, and it can monitor and moderate in real time the demands from that whole environment. And it makes those changes that we would have to make manually automatically. It can recommend the changes, or when you start to trust it, you can get to the stage where it makes the changes dynamically. If an application needs more CPU and it has the capacity for that, then it can demand and get from the system more CPU. And VM Turbo will be able to allocate additional CPUs. If it no longer needs them, VM Turbo can remove those CPUs from that application. Those were the things that we had to do manually and might take weeks to find out and hours in some cases to make those changes. Now with VM Turbo, that can happen in seconds and will continue to happen all day, every day. On top of that, VM Turbo will give us that management capacity to be able to see those changes, to understand what those changes mean, and to see the long-term changes in supply and demand. So it gives us the capacity to plan. Do I need more compute? Where do I get it? Would it be better in in infrastructure as a service, or do I need to extend my own data center capacity? So it understands the capacity and lets us manage that capacity. So that's a really important component. All in software. Another layer for us is handling multiple applications. We've said one of the big advantages of this kind of environment is the ability to spin up multiple copies of applications to deal with peaks and troughs in user demands. But that's no good unless my users can reach those applications. So as a new application is spun up, something needs to do the balancing. Something needs to be able to be aware of that new server instance, wherever it might be, and to make users able to connect to it. So what we need there, and a component we have in this one, is the array networks application delivery servers. Now those can be hardware, the conventional hardware, but you'll gain much more advantage if they themselves become software within the environment. Simply instances, virtual instances, dealing with the moderation and load balancing of application and application delivery to our users. In an integrated environment, as a new server is added to a pool that a user needs to use, the array application delivery servers will be informed, will add that to their set, and will automatically start to load balance the user's requirements across that new server. And when that server is spun down because it's no longer needed, capacity is no longer required, that change will again be instigated within the array application delivery server, and the pool will shrink accordingly. All done in software, all meeting the changes in demand dynamically, and all done in seconds. So that's what we aim for. There's no use having all of that if it's possible for something to get into our data center, and it will happen. Once something gets into our data center, if a threat actor finds a loop, some weakness in the system, they will get into that network. And once they're in a conventional open data center infrastructure, there is nothing to stop them. We will see lots of what we call east-west movement. They'll be able to leverage the services they've got available on one server and move to another, move to another, and move to another. They will move towards the targets that they're after, the data that they're interested in. And they'll be able to allocate servers within that set and move that data out. They'll find the weakness that allows them, the paths, the network paths, the application paths that allow them to move their data that they regard as theirs now out of your network. So we need, in this massively virtualized infrastructure, we need separation. And the best way of doing that is microsegmentation. And microsegmentation allows us to determine and control the movements within that data center. So nothing can speak to something else without it being moderated. And the component we use for that is VArmor, a distributed firewall component across the entire data center infrastructure. It is able, with a very light footprint, to see everything that's going on in the network and to separate at application levels, at server levels, the traffic that's allowed to travel from one side to another through the data center. So everything, all movement through it, we have visibility of. If we have visibility of it, we can make decisions about it. So it's all about visibility and control. One last component there is the software-defined wide area network. We've got virtualized everything else, but if we look at a larger enterprise infrastructure, we're more likely to have, more than likely than not, to have more than one data center. We might have 2 data centers, possibly 3, possibly 50, if you're a Google or whatever, but you'll have more than one data center. Add to that infrastructure as a service. Maybe you want to burst some of your workload into that infrastructure as a service when you're busy, when your current data center is reaching the end of the month and it's very busy. Maybe you want to put some in there. Maybe you have some permanent infrastructure that you operate within Amazon or Azure or wherever it might be. And maybe there's been a decision to use some genuine cloud components, like, for example, Salesforce.com. But one thing for sure, if you're running Salesforce.com or any of these others, Workday or anything like that, there will be elements within your fixed data center that need to be able to communicate in both directions with these applications, to share data, to receive reports, whatever it might be. So what matters then is our ability to change and treat the wide area network as malleable and as changeable. So by adding a virtualization layer there, we have the software-defined wide area network, and the component we use for that is Silver Peak. And Silver Peak with Unity allows us to do that between data centers and into cloud and infrastructure as a service components, giving us the ability to rapidly make changes, use the best wide area networks that we have available, the best utilization, to compress and optimize the traffic that travels through that wide area network, and to get the maximum utilization of the bandwidth available, and therefore the minimum cost. So the software-defined wide area network is that last component that gives us the fully software-defined wide area network and the fully software-defined data center. That is Webscale with Unity. Okay, that's enough from me. I'm sure there will be questions, there will be some time at the break, but in the meantime, let's fill in those building blocks with discussions from a number of our vendors that are joining us today. Thank you.